Hi, I'm Craig the geologist. It wasn't all that long ago that we were talking about what rocks are and how they form. And integral to that talk was the rock cycle. Seamless edit. So this is the rock cycle here. And all rocks start out really as igneous rocks. And they might undergo metamorphism to become a metamorphic rock, or they might break down to become a sedimentary rock. And a sedimentary rock might remelt if buried deeply to become igneous, or more likely it could be buried deeply and undergo metamorphism. Of course, metamorphism can lead to remelting of the rock and becoming igneous, or the metamorphic rock can come to the surface and weather out and become a sedimentary rock. That's the basis of the rock cycle. But it's not the only cycle on our planet. There are other cycles, some of which you may remember from grade school. The water cycle, for example. Now, I'm not going to draw that up on this board because the water cycle is typically illustrated with a very complex diagram showing landscapes and clouds and evaporation and precipitation and stream systems. But you can hopefully remember it from school. But it's also not just rock cycle and water cycle when it comes to earth science. Very important is the salt cycle. And we actually didn't know about the salt cycle until relatively recently, at least the last 50 or 80 years. In fact, we used to think salt took a one-way trip to the ocean, and it led to scientists wildly underestimating the age of the earth because we didn't know that salt left the ocean and was cycled back through the crust in various processes. But salt cycle, water cycle, rock cycle, those are still not the only cycles in earth science. There is a nitrogen cycle, a phosphorus cycle, a carbon cycle. You might be more familiar with the carbon cycle. There is a mercury cycle. There is a carbonate silicate cycle. There is a cycle for just about everything. Why is that? Well, here's a list of the major cycles on Earth. And this is not an exhaustive list. This is not all of them. These are just kind of the major ones. The reason that we have so many different cycles in our systems on Earth is that Earth is, for the most part, a closed system. We can treat it as a closed system. That is, it's like an aquarium, a fish tank that's sealed off from everything. All right, so we do have energy coming in. We do have light and heat from the sun, as well as a little bit of atomic material from the solar wind. And we do lose a little bit. We do lose hydrogen and helium from the upper atmosphere. But generally speaking, we can treat the Earth as a closed system. We can treat it as a system where nothing goes in and nothing comes out. Which means anything that we have on the surface has been around for about 4 billion years. It has to either be stationary and immobile, not going anywhere up here, or it has to be able to undergo a cycle. There are materials that we don't see on the surface of the Earth because they don't undergo a reliable cycle. For example, while we have a lot of iron, most of the Earth's iron is in the Earth's core. It's a good example of a material that doesn't undergo a cycle, and so it just got buried away and never came back. But in a closed system, recycling is a major thing. Materials are used up in different ways on the surface, but they don't disappear. They might end up being buried, or they might go into a sink of some sort, like the oceans. But there are other processes that then retransport them and keep cycling them around. For example, the salt cycle, yes, salt goes into the ocean, but salt also makes its way into the rocks beneath the ocean and creates metamorphic suites that are very high in salt content that can then remelt into the mantle, into magmatic material that is then erupted from the surface, and so the salt cycle continues. So all of the materials on this list here undergo some sort of a process akin to the salt cycle. Each one of them different, each one is unique, very different from the others, but they all undergo this recycling that keeps them refreshed in our crust and at the surface of our Earth. Each one of these is a fairly interesting cycle, very complex. I could spend an hour talking about each of these, but I won't because I don't find that interesting enough. I know you don't. So we're going to focus on this channel talking about the rock cycle. We may talk about the water cycle a little bit. We might get into the salt cycle at some point, but yeah, it's pretty dense material. But yeah, to summarize, there are a number of cycles on Earth. And why is that? Well, every material you see on Earth has to either be completely stationary, immobile, unreactive, and not involved with anything, or it has to be able to undergo a cycle to be constantly refreshed. And that's what we got here. The carbon cycle, for example. Limestone locks away carbon in carbonate rocks, but acidic waters free up that carbon and it goes into the atmosphere as carbon dioxide. Sunlight enters the earth, plants photosynthesize that sunlight and carbon dioxide and convert the carbon into organic molecules. Those organic molecules, when the plant dies, are buried and they either rot and go back as carbon dioxide into the atmosphere, or they're buried away and undergo processes to become hydrocarbons. And then they're locked away forever until they're released by geologic processes, or more likely nowadays, drilled down to and placed into our cars and burned, and the carbon dioxide goes right back up and the cycle continues. So our closed system Earth is the reason why there are so many cycles on our planet. Because if it's a material you encounter at all, it has to either be completely inert and immobile to have remained on the Earth's surface for 4 billion years untouched, or it has to have some sort of a cycle through which it's refreshed and constantly replenished on our surface. And that's why you have all of these cycles here. The most important of which for our purposes are the rock cycle and of course water cycle for sustaining life. Carbon cycle is pretty important for sustaining life. Salt cycle is critical to the oceans and the function of almost everything. When you get down to it, some of these don't feel very important. An iron cycle, a mercury cycle, but they all play important roles on our planet. So cycles. Our planet recycles everything. And as long as there aren't organisms on our planet throwing everything out of whack, then it's a self-sustaining system. So these cycles explain why the surface of our planet isn't just a barren plain, which is what it would be without the water cycle, the rock cycle, and all these other cycles. Every material you've ever encountered is generally involved with a cycle of some kind on our planet. I hope you found that interesting. Join me next time. I'll probably talk more about rocks.